9.1 Example 2. In this example, we're going to be looking at how to identify a convergent series. So we're going to look to see, and we're going to look at a sequence, and we're going to see if this series converges. So the sequence in particular that I'm looking at is 3/10 plus 3/100 plus 3/1000 plus ... plus 3 over 10 to the n. So each time you're multiplying by 1/10 to get from one term to the next. So in order to do this, we have to basically start looking at the sums. So notice that 3/10 is 0.3, 3/100 is 0.03, 0.003, and so on. So each term you do another 0.0 in front of the 3. Okay, so the sum of my first term is 0.3. The sum of the first two terms is 0.3 plus 0.03, which is going to give me 0.33. The sum of the first three terms is 0.3 plus 0.03 plus 0.003. So I get 0.333. And if we kept going, if we did the sum of the nth terms, we would get 0.3333333 forever, which is going to be 1/3. So because when we do our infinite series, we get a number, which is 1/3, we get that our series converges to 1/3. On your own, I want you to now try to see if this series converges or diverges. And if it converges, what does it converge to? So go ahead on your own and give that a try. Alright, so let's go ahead and see if it does converge or diverge. So the sum of the first one is 1/2. Then the sum of the first two is going to be 1/2 plus 1/4, which is 3/4. The first three is 1/2 plus 1/4 plus 1/8, which if we have to combine fractions, we get 4/8 plus 2/8 plus 1/8, which gives me 7/8. Sum of the first four terms, we're going to have 7/8 plus 1/16, which is 14/16 plus 1/16, which is 15/16. Now we can notice that every time this fraction is becoming closer and closer to 1. So if we did this in our calculator, it might help. So you might want to write out a bunch of terms and put them all on your calculator. And if you actually put that long string of numbers in your calculator, you get 0.9990234. And so this actually shows that we're actually converging to 1. So it does converge. And it looks like it converges to 1. So what I want to show you real quick is why this converges. Basically, we're taking half each time and adding it to itself. So if we have a square, so what we have here is if we look at this square, which we can think of as one complete area, and we start halving it and adding those halves to itself, we can see that over time, we're going to get one full whole object. We get 1/2 plus 1/4 plus 1/8 plus 1/16, and so on. And eventually, if you keep repeating that over and over and over to infinity, it's going to fill in the box and make 1. So if you add this series over and over, you get 1.